Here's an ordinary 2-liter bottle. What's in the bottle? Most people would respond that it's empty. But if that's true, how do you explain this? A small piece of paper towel placed on the bottle, and now I'll squeeze. Clearly, something was in the bottle. It's full of air, which is a mixture of gases. If I place the bottle in some water, which I've colored blue, you can clearly see the air emerge. This video is about air, or more properly, it's about gases in general. And the point I'm trying to make is that gases are real. They're substances, they're materials. They have mass, they take up space, just like liquids and solids. There are differences. There's a lot of empty space in gases, but that doesn't mean that they're inconsequential. If you wave your hands in the air, you can feel the air touching your skin. If you go outside, you can feel the wind on your body. And yet, most people just ignore the air because it's invisible. But just because it's invisible doesn't mean it's not real. Here's a demonstration with a funnel. This is an ordinary glass funnel. And what I'm going to do is put my finger over the small opening and then put it down into the water. And let's see what happens. Here's the funnel, finger on top, and down into the water. You can see there's air inside the funnel, or at least there's not water. Now if I take my finger off, the water fills the funnel. So clearly the air was taking up space. Let me do a few more demonstrations along the same lines. Here's an ordinary plastic cup. I'm going to take a paper towel and ball it up and put it down into the bottom of the cup. And now I'm going to put the cup upside down into the water. What do you think is going to happen? Watch. When I take the cup out, the paper towel is perfectly dry. Air took up space and did not allow the water to reach the paper towel. Here I have a small styrofoam ball. It will float on the water. If I take my cup and put it on top of the ball and press down, watch what happens. The ball goes down. Clearly, the air is exerting a force on the ball and making it go down just like the cup. So clearly, the air is a material and it can exert forces. That means it can do work. And most people don't realize it's doing work all the time. Watch this neat trick. I have a cup here. I'm going to put some water in it. This is an index card, ordinary paper. I'm going to put it on top of the cup, put my hand over it, turn it upside down, and now take my hand away. Isn't that cool? The air here in the room is exerting a pressure in all directions, including upwards. And that pressure is enough to actually hold the weight of the water up, as long as there's something blocking its path. Now, if I make the tiniest hole, the air pressure goes inside the cup and then presses down. But when I inverted the cup like this, and there was very little air left in the cup because that's where the water used to be and I blocked the air from getting in there, there was a great difference in air pressure. Very low air pressure here, large air pressure here. It was enough to keep that water in the cup. If you thought that last demonstration was neat, wait until you see this one. Here's a paper towel. I'm going to tear off a very small piece of it. In fact, I am going to split that in half. Actually, maybe even about a third. Ordinary paper. I'm going to get it wet. And here I've got a flask of water. It's a 500 milliliter Erlenmeyer flask, full almost to the top. I'm going to put the wet paper over the top of it. Seal it up a little bit with my fingers. Put my hand over it, invert, and remove my hand. That's a wet paper towel, folks, holding in all that water. Actually, what's holding it in is the air. You can't see it, but it's there and it's doing work. If I touch the paper towel and allow just a little bit of air to equalize the pressure, all the water comes out. You could clearly see the air coming in, getting up here, and now it can press down with as much force as it presses up. So most of the time, we don't think about air pressure because it's pressing equally in all directions. It's only when it has unequal pressure that we notice this movement. Most people don't think about it a lot, but we are actually on the bottom of the atmosphere. It's like being at the bottom of an ocean, except an ocean of air. And so there's air all around you, and it's pressing on you all the time. And that pressure is actually quite impressive. In fact, on every square inch, there's about 14.7 pounds of air pressing on your body, on your desk, on everything around you, right now. Here's an ordinary newspaper. Oh, too bad. Looks like Trinity beat Mel in baseball. That's sad. But I've put on there a square inch. On that square inch right there, there's almost 15 pounds of air hitting it every second. In fact, on all the square inches of this paper, 15 pounds here and here and here and here, and it adds up. Let me do a little demonstration for you, just to show you how much pressure we're talking about. Here's an ordinary meter stick. Well, not really ordinary, science rules. If I put this on the tabletop, leave a few inches hanging over the edge, and I hit this with my hand, you can watch the ruler flip right off the table. Now I've placed a newspaper on the end of the meter stick. That newspaper has a lot of air pressing down on it, and what I've tried to do is press as much of the air out from underneath it as I could. So it's lying flat on the table, and I've tried to spread out all the wrinkles as best as I can. Now, if I walk over here to the end of the stick that's poking off, and this time, if I strike it forcefully and quickly, let's see what happens. Science! Well, unfortunately, the stick fell out of camera view, but I actually broke the end of the stick off using my karate chop of science. The newspaper had a lot of air holding down this end of the stick, and it was actually able to hold it in place long enough for me to forcefully break the other end. In fact, that newspaper is 21 inches by 22 inches. That's an area of 462 square inches. If you multiply 462 by 14.7 pounds per square inch. That's nearly 6,800 pounds of air on top of that newspaper. I drive a Toyota Camry, and my Toyota Camry weighs about 3,400 pounds. In other words, there's 2 cars worth of air on top of this newspaper when I laid it out flat. That's a lot of force. I did it again in slow motion for your entertainment, and again it worked. About 6 inches of the stick broke right off because thousands of pounds were holding down the other end. So if you got nothing else from this video, I hope you learned this. Air is a material. It's made of gases, and gases have physical properties like mass, force, pressure. And so the next time somebody asks you, is the glass half full or half empty? You say neither. It's always full. It's just that this half is invisible, but that doesn't mean that it's not real.